So next is Phillippe Siclait from Airbnb. Phillippe is actually a software engineer, and he's a founding member of Airbnb's AI lab. He started at Airbnb in 2012, and he was one of the early search engineers. Without further ado, Phillippe Siclait.
Can everyone hear me? Yeah? Okay, cool. So today I'm going to be talking about a project that we worked on recently at Airbnb on image classification. For a little bit of context on Airbnb, we are a platform for finding accommodations and experiences all around the world. And the particular part of the product that I'm going to be talking about is the search experience. So the search experience on Airbnb is focused on finding a listing. In particular, we're going to focus on places to stay. And the way that we present the results is, with a page that looks a lot like this. So you can see all of the different homes on the platform. For each one, there's a carousel of images that you can go through. And then there's also additional information, including the title of the listing, the price, and the review score. And the problem that we wanted to solve with this project is focused on the images in particular. So the images in search are varied. This is a search in San Francisco. And one of the things we can see at the top is there's an image of the Golden Gate Bridge for a listing, which doesn't tell us anything about that particular listing other than it's in San Francisco. So what we'd like to do with this project is use the actual content within the images to determine which image to show. And the particular example that I'm going to show here is for a user searching for a private room on Airbnb. So the problem with searching for a private room, so for some context, Airbnb has private rooms, which are individual rooms that you can stay in within a larger home, possibly with the host present. There's entire space, which is the entire home to yourself. And there's shared room where you have like a couch or some pull-out bed somewhere in the space. So for a private room, you'd think that the thing that would be most important to the person is the bedroom. And yet you can see here that we don't actually have many bedrooms actually being displayed. So what we'd like to do is reorder the images based on this content. And in particular, the images that are outlined, I'm not sure if it's super easy to see, are the ones that we'd like to reorder. So our solution is to build a machine learning model to classify the images by their room type. To be specific, what this model does is we have a series of binary classifiers. So there's either one option or another option. And each binary classifier is like kitchen, not kitchen, bathroom, not bathroom, bedroom, not bedroom. And our model outputs these different classes. So then on the product side, we have these outputs available. And then we can use it to determine which image to show. So in the case of this particular version of the experiment, what we do is if someone's looking for a private room, then we ensure that the first image that's displayed is of the bedroom. And I can talk a little bit more about the solution itself and how we built it out. So the idea was to build essentially scalable infrastructure for image classification. And I mean scalable in two different senses. One, we just have a very high volume of images, or very high not compared to Google or Facebook, but like reasonably high volume of images. And the other thing that we need is a system that can scale out to different types of classification models. So in this case, we have a set of 6 different models for different room types, but we'd like to be able to add additional types of classifiers in the future. The way that we ended up setting it up is the system ingests the images from the site, and then first we turn the images into thumbnails, so small 224 by 224 images. And the reason for doing that is to decrease the amount of processing time on all these images. Processing large images just takes a very long time, and decreasing the size kind of helps with that a bit. The next stage is to use a convolutional neural network, which is a type of model to take in that image thumbnail and then output some representation of that image. So I won't go super deep into the details on that, but the way that we did it for the first pass is to use a model that exists out in the literature and where there are open source implementations. And it's a model that has been pre-trained on a data set called ImageNet, which was developed by Fei Li's group at Stanford, to generate this representation. And the representation is just a list of numbers. The interesting thing about this representation that's output is that the representation for two images that are similar to each other, those representations tend to also be similar to each other. And given that there is that attribute of these representations, then they work really well as inputs to these classification models, which themselves are small neural network models. Yeah, and then at the bottom, I have some of the technologies that we use to build some of this out. The final stage is that once we've determined all of these different image classes, what we have is for each image on the site, is this a kitchen or not? Yes or no. Is it a bedroom or not? Yes or no. Is it a bathroom or not? Yes or no. And then we can just display that, or essentially serve that in a table to the product. So then the product engineers just have to read in those values, and then they can add whatever business logic they want on top of that to determine what to do in the product. So a few of the challenges working on this. One, our initial attempts at training the models used images that did not reflect like the images that users in the real world would see. So this is actually a pretty common problem. And it's one that is sometimes obvious and sometimes less obvious. I can go into the particular set of issues that you'll see there. One is it's really easy to get high quality images. So an image of, let's say, a kitchen that has the entire kitchen contained within the image. It's a sort of thing that you'd find from some catalog. It's not really representative of all the images that we have on Airbnb. And you can train a model on these images, and what you'll find is that it does really well on similar sorts of images, and then it does really poorly on the poorly lit images, the images that are zoomed in on some portion of the kitchen, the images that, for whatever reason, don't really match that sort of image. So the broader problem is making sure that the test distribution, so like the distribution of your problem that you're trying to target, actually matches the distribution that you find in your real production data. The second, training neural networks is difficult. And what I mean by that is that there isn't necessarily a completely deterministic process towards getting to the fully trained model. You have to do a lot of experimentation. There's a lot of trial and error with the different parameters of the model. There's trial and error with the data as well. You'll try out training on some set of data, and then you'll look at the results of your model and see where there are errors, and that'll inform you on how you should iterate going forward. And that just makes the entire process a little harder to predict in terms of how long it will take. And it also makes it a little bit more challenging for the person working on it, because oftentimes what this means is the individual just kind of needs experience building out these similar sorts of models to discover the pitfalls that exist. So one good source of information on this is actually on Coursera. There's a deep learning specialization that was recently released, and I went through the courses to check them out, and there's pretty good information on some of the practical concerns when training neural networks. Then the last one, getting the data pipelines off the ground. So for this particular project, I outlined the way that we set everything up, and for this problem, it probably doesn't justify the amount of effort that it took. However, now that we have all these data pipelines in place, we can build other image classification models on top of this, and that is what made us decide to actually go through with this project. So then a little bit on the outcome. We built an experiment that wouldn't have been possible without machine learning. Getting the content of an image, determining what is actually there, is a challenging problem. It's one where if we were try to do this without machine learning, heuristic methods probably wouldn't work very well. And so we could only do a small scale experiment if you had to have humans label every single one. The rate of image uploads on the site is somewhere on the order of several 100,000 a day. I think that's right, maybe more. And so, yeah, it's just not feasible to label all of those as they come in. Then another outcome, and this is tied to the point that I raised before on the difficulty of getting a model like this off the ground, is now that we have this infrastructure in place, there are a lot of teams who are really excited about using this technology for different problems that they've faced that they haven't been able to solve in the past. So a few of these potential projects include listing quality prediction. So there's a lot of information contained in the images, and when people book listings on Airbnb, some of the first things that they look to are, outside of price and location, the images and the reviews. And both of those are unstructured data that prior to some of the recent work that we've done, we haven't really been able to glean that many insights from. Another is listing creation assistance. So in the same sense, we can help people choose the best images instead of just choosing the images for them. And automatic amenity determination. So we can look at the images to determine what sorts of amenities they have. One good example is a swimming pool. We can do a pretty good job of identifying swimming pools in listings, even if the host forgot to include that in their amenities. This experiment is still running and being monitored via our experiment reporting framework. Yeah. Are there any questions? Yeah.
So what was your error rate initially when you started classifying these images?
Yeah, initially, I think the first pass, so I mentioned the problem of the image distribution in the test set. So initially, we were getting, I think, 70% accuracy on the model. And so that was a pretty quick first pass on a smaller data set just to validate that things could work. And that was enough to justify going forward.
And how did it go down as time went by?
Well, that was the accuracy. And so the error rate went down. I'm trying to think of, well, it's different across the different models. And right now we are at, so I guess to go into the specifics, what we ended up doing for this problem is we targeted a reasonably high precision threshold, and then ended up getting, and so we have the accuracy at that precision threshold. And I think it's still around, it's around 85% or so. Yeah. Yeah.
Yeah.
Was the goal to take the images that were displayed and rearrange them so the bedrooms were at the top, or to select the bedroom image from the, 20 images that you were uploading and show that?
So for this particular project, we look within the full set of images for the listing and then find a bedroom image, one where we're highly confident, and bring that to the front. Okay. Yeah, thanks.
Thank you, Philip.